For these next few example problems, we'll be looking at the probability that certain guests meet certain qualifications or variables. Above, there are 4 guests described, including their age, their gender, their preference for Sox versus Cubs, and their preference for light meat versus dark meat on the turkey. The first question asks us to look for a basic probability. When they ask for just probability, we're looking for a simplified fraction. So the probability that a guest will want light meat. Well, there's 4 guests altogether. That's my total outcome. That's my sample space. There's 4 of them. The first guest, guest A, likes light meat. The next 2 like dark meat, and the last one likes light meat. So only 2 out of 4 like light meat. I need to simplify this fraction. There are many methods out there, and this is a simple enough fraction, but let's refresh on the double mountain method. For double mountain method, you draw 2 mountains. I need to find the factors for both my numerator and denominator. The factors always start with 1 and the number, so 1 and 2. 1 times 2 makes 2. Those are the only 2 factors. For 4, I always start with 1 and the number. 1 times 4 makes 4. Climb the mountain on the left side. 1, 2, 3, etc. 2 times 2 makes 4. 3, well, it's already on the other side of the mountain, so I need to stop finding factors at this point. I'm going to find the biggest number in both lists. 2 is the greatest common factor, the GCF. I divide top by 2, bottom by 2. There's my fraction. I have a probability of 1 to 2. This next question asks for the percent probability. So we need to find the probability as a fraction and then turn it into a percentage, which means we don't necessarily have to simplify first. We're looking for the percent probability that a guest will want dark meat. There's still 4 guests in my sample space. That means I have a total outcome of 4 outcomes. There are 2 guests that like light meat, 2 guests that like dark meat. So that's a probability of 2 out of 4. I could simplify it. In fact, we just simplified this. There are a couple ways to turn a fraction into a percentage. Since percent means per 100, you could set up a proportion with 100 in the opposite fraction's denominator and solve for the numerator. The simplest way is always to divide numerator divided by denominator. So quick calculator moment, 2 divided by 4 gives me 0.5. Then I'm going to move my decimal place 2 places to the right. Since I'm multiplying the decimal by 100, that moves the decimal 2 places. So 0.5 is 50%. What's the probability that a guest is a male and is under 30? When you have and probability, you're going to multiply the 2 probabilities together. So I need to find each of the individual probabilities. So the guest is male. There's still 4 guests in my sample space. There are 3 females, 1 male. So the probability that he's male is... Now I need to find the probability that a guest is under 30. There's still a sample space of 4 total outcomes, so 4 guests altogether. Of those guests, 3 of them are under 30, so that's a probability of 3 out of 4. Since it's and probability, I'm going to multiply. I do not need common denominators. I can multiply straight across. 1 times 3 is 3. 4 times 4 is 16. If I wanted to try to simplify that, I could set up a single mountain, double mountain, anything like that. It's just going to remain 3 to 16. 3 is already a prime number. Prime numbers don't mean it's necessarily unsimplifiable, but it's usually a good indicator. What is the probability that a guest is a female or is under 30? With or probability, you have to add the individual probabilities together. So first I need to find the probability that a guest is female. I have 4 total guests, of which 3 are female. That's a 3 in 4 probability. The probability that they are under 30, we just found, there's 4 total guests, 4 total outcomes, and 3 of those are female. So I'm going to add those fractions together. Luckily, they already have common denominators. 3 plus 3 is 6. My denominators do not get added together. The denominator's like a last name. 3/4 plus 3/4 is 6/4. 6/4, both numerator and denominator are even. If I divide both top and bottom by 2, I get 3 to 2. So I have a 3 to 2 probability. Do not turn improper fractions into mixed numbers. For probability, you want to leave it as just an improper fraction. It's better to communicate the odds or the probability. Guest B has a 3 to 8 probability of causing a fight, so he caused a lot of drama at family events. If he attends 24 Thanksgivings, how many fights will he cause? In this case, we need to set up a proportion. Here we're using our odds, our probability, to make a prediction. So I'm going to take my original probability, 3 to 8, and then I need to set up my proportion. If he attends 24 Thanksgivings, that's the total number. That's our total sample space, all of our outcomes. So that's going to be in my denominator. My unknown, the value that I want to know, is how many fights. In order to solve a proportion, we just cross multiply. 3 times 24 divided by 8 gives me 9. So you would cause 9 fights. The dessert tray has 10 cupcakes, 15 slices of cheesecake, and 25 cookies. What's the probability that a picky guest picks up a slice of cheesecake, puts it down, and then picks up a cookie instead? In this case, we have to understand a couple pieces of information. If we're figuring out the probability of items happening or events happening in order, we're treating it like and probabilities. We're multiplying the individual probabilities together. It's also important to note that because the cheesecake was put back on the tray, the total sample space, the total number of outcomes, never changed. So when I create my probabilities, I don't need to change my outcomes or my specific events. So I need to find the probability of picking up a slice of cheesecake. There are 15 slices of cheesecake out of a total of 50. In this case, they didn't tell me the total outcomes, so I had to add 10 plus 15 plus 25 to get 50. So this is a probability of 15 over 50. Now I need to find the probability of picking up a cookie. There's still 50 items on the tray. Because they put the cheesecake back, there's still 50. There's 25 cookies out of 50 total items. These numbers are big and scary. If I'm going to be multiplying them together, even though I'll be doing it on a calculator, it'll make simplifying later very hard. Right now, I see these numbers and I can see easy ways to simplify. For example, I know that 25 is 1/2 of 50. Think about those. Those are money numbers. There's 1/4 in 25 cents. There's 2 quarters in 50 cents. I can simplify before I multiply, and that will make my final simplifying a lot easier. It doesn't mean I don't have to simplify, but it lowers the odds, lowers the probability that you'll have to simplify at the end. 15 and 50, well, I know they both are divisible by 5 at least. So I'm going to simplify. 15 is 3 sets of 5. 50 is 10 sets of 5. I'm going to stop there. 3 times 1 gives me 3. 10 times 2 gives me 20. I can check to see if I need to simplify. I could write out my factors. In this case, I'll start with just the lowest number, 1 and 3. 3 is not a factor of 20, so that means it's simplified. If you choose to not simplify before, you can find a final answer. But if you struggle with simplifying, especially simplifying bigger numbers, which will have more factors, I would consider simplifying before you multiply your fractions, or probabilities in this case, together. In this situation, there's a couple things to note. We're still looking at the probability of 2 different events happening in order. So we're still treating it like and probabilities. We're multiplying the probabilities together. In this case, though, the hungry guest picks up a slice of cheesecake and then another slice of cheesecake. They don't put the cheesecake back. So we start with a total of 50 items on the tray. 15 of those are cheesecake. So we have a probability of 15 over 50. We pull that cheesecake off the tray. Now there's a total of 49 total items because we took one away from 50. There's also only 14 slices of cheesecake. So if I want to grab a second piece of cheesecake, the probability is 14 out of 49. There's only 14 slices of cheesecake left on the tray out of 49 total items because we took one slice away. Just like last time, we're going to multiply straight through. 15 times 14 gives me 210. 50 times 49 gives me 2,450. This is a case where I did not simplify before, so some of those factors are still sitting around. One quick tip that always works for simplifying: if both your numerator and denominator end in a 0, you can cross out 1 0 on top for every 1 0 on the bottom. So 210 becomes 21. 2,450 becomes 245. This works because we're dividing both top and bottom by 10. If we do it to the top and the bottom, it doesn't change the overall value of the fraction. Now I can take these two values and find easier factors. 21 is small enough that I could find factors very easily. That's 1 times 21 makes 21. Climb the mountain. 1, 2. 21 divided by 2 gives me a decimal. 21 divided by 3, that gives me 7. So 3 and 7 work. I'm going to keep climbing the mountain. 4, decimal. 21 divided by 5, decimal. 21 divided by 6, decimal. 21 divided by 7, I'm on the other side of the mountain. I know I have all of my factors. In order to see which of these factors is the greatest common factor, I divide the other value, so in this case the denominator, by each of my factors. 245 divided by 21 gives me a decimal. 245 divided by 7 gives me 35, a whole number. So I can simplify by dividing by my new greatest common factor. 21 divided by 7 is 3. 245 divided by 7 is 35. There's my final simplified answer. So there's a lot of great tips on simplifying fractions, since that's all probability is, applied fractions. Remember, these questions mimic the types of questions you'll see in your assessment in class. If there were any particular problems that you were challenged by, go back, rewatch, and review. For extra help, you can go back and look at the learning targets at the bottom of this page. The learning targets connect back to other videos we've watched in the past that might teach each of these individual skills at a greater depth.